We have a system of equations where a natural substitution doesn't really work out very nicely. Notice right here, if you try to get y isolated, you would end up with x squared minus 24x plus 140 all over 2. All right, and so this looks natural. It's what you might try. You're just, just going for it, But right here, if you substitute this object, this quotient, right here, you'd end up with a 4th degree, or what they call a quartic. And of course, that's difficult. It might have some contrived factorization or something, but in general, a quartic, everybody says a cubic is tough. A quartic, of course, is worse. I think it's the last one where you can solve via formula, Galois theory. But anyway, this substitution is theoretically the try, but it doesn't work out nicely. So now, y'all, it wasn't really necessary for me to tell you that the thing had distinct Gaussian integers. Gaussian integers are just in the form of a complex number where the real and the imaginary parts are integers themselves. And of course, I is the infamous square root of -1. Now, you can tell by inspection right here that 10, 0, and 14, 0 are solutions to just the bottom equation. And of course, that's because right here you have x minus 10 times x minus 14. Okay, and of course, 10 and 14 make the right-hand side 0, so that would force y to equal 0. Okay, so that's where these two solutions come from, but note that they're just solutions to this equation. And you can verify that they aren't solutions to the original. So this doesn't work out here. So let's move along. Now, the idea, folks, is to rewrite this in an equivalent way where 2y equals this presents itself, okay? And so what I'm going to do, folks, is just, let's see, what do I need to do here? I'm going to take away 24x from both sides. See, what I did right here is, you can see what happened on this statement right here, is I got rid of the 24x. I brought it back to this side. So you see how that makes this. Then also I added, 200 to both sides? If you add 200 to both sides, you end up with this equivalent statement right here. Okay. Now, I green this out because if this is just 2y, right? I mean, that was the purpose, is to get 2y to present. And again, it was just two operations from this first equation that led to this equivalency, okay? We're bringing the 24x over to make it a minus, then adding 200 to both sides, right? Or is it 140? I'm sorry, 140. Do we add 140? Yes, we added 140 to both sides to get that to happen. My bad. But anyway, now that we know that this is something, we know what 2y equals to, right? So we physically replace it with what it's equal to get this. Okay, in other words, 2y squared, I replaced it right here. You can just see it turns into a quadratic in y. All right, and so then we end up with this statement right here, and this factor is nice. So this is by design. This is y plus 10 times y plus 20. Right. Now, the idea is to solve for this, which is easy enough, and then you just substitute that back in to the top equation. Okay, and so y equals -10 is certainly one of the solutions, right, to this equation. Y equals -10. And so what happens, this is what happens when you take the -10. Do I have it on the same screen? Yes, yes, yes. You take y equals -10 and place it here to get 100, then place it here to get plus 280 that you see right down here, right, folks? Okay. So again, this is just a direct substitution into the top equation. All right. This results in a quadratic. I won't bore you with all the details, but you get x is equal to 12 plus or minus 4i, which is certainly what we would call a Gaussian integer. It's two of them, two Gaussian integers, all right? So what this would correspond to as far as ordered pair solutions, you would have 12 plus 4i as an x-coordinate, mapping to -10. And again, -10 is an ordinary integer, but it's also just a Gaussian integer with a zero imaginary part. All right, and so let's see what else. 12 minus 4i. I should have just written plus or minus here. 12 minus 4i also corresponds to negative 10. Okay. So those are two of the solutions in both this Gaussian integer coordinates. And then down here, within a similar way, you get this. And I won't, I didn't go through all the work here, but you get a quadratic in x here, just like we did up here. And then you end up with x is equal to 12 plus or minus 6i. Again, I'll let that work out. So I'll just be sloppy right here and say that's 12 plus or minus, what I should have done up there, 20. Okay, for the y coordinate. Alrighty. Okay, folks, so that does it. There are 4 solutions here, 1, 2, and then this represents 4 solutions. So there's 4 solutions right here. There's 2 of them. Okay, and then here's the other 2. Okay, so that's all. And again, it's not the best problem in the sense that knowing that this had Gaussian integer solutions didn't direct your action. You carried on like you would have normally carried on. The part I thought was slightly sneaky was that there's no immediate, just direct, straightforward substitutions in this system of equations. But if you rearrange it in an equivalent way by shifting some terms around, the 24 comes to this side and then 140 moves, then you actually get 2y to appear in the middle of an equivalent equation. Okay, that's what makes it cool. And then you get the quadratic in y, which again, like all good math problems, they're designed to work out. They're worked backwards, and the problem solver has to go in the other direction. Yeah. But anyway, I think that's all I have to say. And thank you for viewing.